In the previous video, we looked at how angles are measured using degrees. This angle would measure around 30 degrees. A right angle would measure 90 degrees, a straight line 180 degrees, and one complete rotation 360 degrees. Do you know why 360 degrees? It's somewhat arbitrary and had something to do with the base 60 number system. Do we have some other way in which we can measure angles such that it makes a little more sense? Yes, that brings us to the concept of radians, and trust me, not many people understand what radians mean. Most people know how to convert from degrees to radians and vice versa, but it ends there. To understand what radians mean, let's draw a circle. Let point O be its center and length R be its radius. Now let me take this length R and place it here at this point. Now all I do is push it onto the circumference of the circle. The length of this red part is still R, it has just become curved, and that's all. The curved length R starts from here and ends here. Now, from the center of the circle, we draw another radius that joins the other end point of the red curve. This length will also be R as it's the radius. Let's analyze the figure. We have an arc of length equal to the radius of the circle and two radii joining the center and the endpoints of that arc. Remember, the length of the arc is equal to the radius of the circle. This angle formed here is 1 radian. That's the concept of radians. Actually, there's radius everywhere around this angle. R, R and R, and that's probably why they call it radians. According to various scientists and mathematicians, this is a more logical way to measure angles. It's because we are measuring the angle in relation to the radius of the circle. But how are radians related to degrees? What would this angle be equal to in degrees? If you understood the concept of radians well, then understanding the conversion between degrees and radians would be a walk in the park. What is the circumference of a circle? It's 2 pi r, where r is the radius of the circle. We are talking about the circumference, which is the entire boundary of the circle. Now listen to the next question well. How many such arcs would you need to cover the entire boundary of the circle? Let me repeat the question. How many such arcs of length r would you need to cover the circumference of the circle? Pause the video and see if you can work through this on your own. The length of the arc is r and the circumference is 2 pi r. Yes, 2 pi r. It means we would need 2 pi such arcs to cover the circumference. 2 pi arcs? What does that mean? As pi is approximately 3.14, we would need 6.28 arcs to cover the circumference. How would it look? This is 1 arc, 2, 3, 4, 5, 6 and a little part left for 0.28 arc or 28% of an arc. So we need 2 pi arcs to cover the entire circumference. And what does each arc correspond to at the center? We have seen that 1 arc corresponds to 1 radian at the center. It implies that to complete 1 full rotation, we would need 2 pi radians. And it tells us something more too. If we rotate 1 arm completely, then 2 pi radians will be covered at the center. But wait, hold on. We also know that 1 full rotation equals 360 degrees. Yes, 1 full rotation equals 360 degrees. As both equal 1 full rotation, these two will be equal. 2 pi radians will equal 360 degrees. That's the relation between degrees and radians. This is what we have been working towards in this video. If we understand this, we can easily derive the rest. This is 1 full rotation. Then how many radians will 180 degrees be equal to? If we divide this equation by 2, we get pi radians equal to 180 degrees. And 180 degrees is half circle or a straight line. And what about a right angle? If we divide this equation by 2, we get pi over 2 radians equal to 90 degrees. So a right angle is equivalent to pi by 2 radians. These three relations are most important when it comes to conversion between degrees and radians. And we don't really need to remember all three. Knowing just one is enough and we can derive the rest. And now we come to the last and the most important point of this video. What does 1 radian equal to in degrees? If we divide the first equation by 2 pi, we get 1 radian as 360 over 2 pi degrees. Substituting the value of pi as 3.14, we get the approximate value of 1 radian as 57.2958 degrees. That's the degree measure of 1 radian. If we have an angle like this, which measures 1 radian, it will equal 57.2958 degrees.